Okay, so here's some skills you'll need for your homework. Let's suppose that I have an integral of, let's say, x cosine 2x squared plus 1 dx. And this is an indefinite integral because we don't have limits of integration right here. We don't have any numbers here or here. They wouldn't be x's anyway, but anyway, we don't have anything there for, I guess I should have said, okay, so these are some skills that you'll need for your homework on Delta Math and out of the packet. This is an indefinite integral. It doesn't have limits of integration, so we'll have to just integrate it and say plus c. First thing I would check and see is if I could simplify it or if I even need substitution. Please always check that first. Like if you had something like this, I would just distribute and take the integral. All right, in this case though, I'm going to let u be 2x squared plus 1, the part that's in the most complicated position. Du is 4x dx. People do it different ways, but I think if you do this the same way every time, it'll be easier. So I usually get my coefficient over here, and then I come over here and I count for everything. I have cosine, so I took care of that. I just wrote it down here. 2x squared plus 1, I took care of that. That's u. And what do I have left is x dx. X dx is 1/4 du. I suggest taking your coefficients out. So then you have 1/4 cosine u plus c. That would be your answer, okay? That's what you would do with an indefinite integral. With a definite integral, I don't ever put this back in. All right, with an indefinite integral, I change everything over to fit this nice little simple u, like this. If I have the integral of x squared times x cubed plus 7 dx from 1 to 4. Let's make it 1, 2, 3, just so the numbers are small enough for us to think about. All right, so I'm going to let you, well, first of all, I wouldn't even use substitution here. That's real important. I would not use substitution here. So it's actually a good example. I would just distribute and take the antiderivative, okay? However, if it said this, I wouldn't want to multiply all that out. So I would use substitution. So make your decisions wisely. This is x cubed plus 7. Du is 3x squared dx. So I get 1/3 du equals x squared dx. So I have the integral. All right, x cubed plus 7 is u. So that's taken care of, cubed. X squared dx is right here, and it's 1/3 du. Now, I'm also going to change my limits of integration to fit u. So I'm going to fill in 1 for x, and I get u is 1 plus 7, 8. Then I'm going to fill in 3 for x, and I get 27 plus 7, which is 34. It's not the best example because these numbers are getting pretty big. But then I would say 1/3 u to the 4th over 4 from 8 to 34. Again, this is really big, but I'll show you another one. So I'm going to make this u to the 4th over 12 from 8 to 34. And then I'd have to fill in 34 to the 4th over 8. So let's change our limits of integration here. Sorry, I had forgotten to get that big, or didn't realize it. So I'm going to take the integral of x squared times x cubed plus 1, let's say, and let's make it cubed dx, and let's go from 0 to 1 just as a good example, so it won't get too big. I'm going to let u be x cubed plus 1. Du is 3x squared dx. 1/3 du equals x squared dx. I use these for my sub. Now I'm the integral. This is u. X squared dx is 1/3 du. then I'm going to change my limits of integration. I'm filling 0 right here for x, and I find out during that time u is 1. When x would have been 1, u would be 2. And then I just work with this nice little thing, and I never go back to x. So the important thing is to get a nice little small integral that's easy, but don't forget to change your numbers to fit u. So it gives me 1/3. That gives me u to the 4th over 4 from 1 to 2. Remember, the 1/3 applies to the whole process. So I get 2 to the 4th over 4 minus 1 to the 4th over 4. So I get 1/3, 15/4. 3 goes into 15 5 times, so I get 5 over 4. Now, you'll run into some friends that say, oh, well, the way I do it is I just put this back in and use my old numbers. Well, it's just going to be more complicated. I would do this nice, sweet, little easy thing, plus AP exams and teachers and Delta Math's going to make sure that you're doing it the best way anyway. So it's real important, if you're going to use U sub, but stop and even think, am I going to use U sub, okay? But if you're going to use U sub, if you have f of some function, whatever you have there, that means it's been put into a function. And if you have your limits of a and b, and you're going to use U sub, then you're going to fill them in for x to find your new u's. So let's do that. All right, so here's some Delta Math exercises. Let me see if I can expand this or get this out of the way. Okay. All right, let's look at this one. All right, so here, this is an indefinite integral. So I'll let u, I don't know why it's not writing. Let's see, sorry. So I'll let u be 5x cubed plus 4. Why am I using substitutions? Because I cannot multiply it out with this exponent here. And then get du is 15 x squared dx. Then I'll make it 1/15 du equals x squared dx. And then I'm going to see what I have. I have the integral of u to the 2/3. I have 5 I'm going to take out here. 3 I'm going to take out here. X squared dx is left, which is 1/15 du. If I had limits of integration, I would also change my numbers right now. Now remember, I've taken care of everything except for this 2/3 power, but I wrote that down. So now the antiderivative, 5 goes into 13 3 times, so I get 1/9. The antiderivative of that is u to the 5/3 divided by 5/3, or times 3/5. Don't forget your plus c. 3 goes into 9 3 times. So my answer would be 1/15 u to the 5/3 plus c. Since I had no limits of integration, I do have to go back to this. So this is what you would type in right here and submit your answer. So what you did was substitution's like a sneaky way to get the right answer. All right, a good creative way to get the right answer. All right, let's look at this one. All right, here I would let u equal x squared plus 9. You do have the option, since it's cubed, of multiplying everything out, but I wouldn't do that if it was, I would probably do it if it's the first or second power. I don't know that I would do a cubed one. That would get pretty big. So I'm going to use u sub. U sub won't always work. It's just always going to work in these Delta Math problems. 1/2 du equals x dx. So now I have the integral of u. X squared plus 9 is u cubed. I have x dx, which is 1/2 du, and I got to make sure I account for the 8, so I'm going to put it out here. So now I have 4. This is u to the 4th over 4 plus c. So I get u to the fourth plus c and put u back in. When I have limits of integration, I never go back. I just stay in terms of u, but I've changed my numbers. Anyway, this would go right in here for your answer. That's just a repeat of that problem. Let's see if this is a new problem. I think I just copied it in there a lot of times. Okay. Now let's look at this problem. Okay, so they didn't even tell us what the function was, but they told us it equaled -8 when they finished. Sorry. So we know it equals -8. So we're just going to rewrite the whole thing, and then we'll fill in what we need down here. All right, so what they mean by this expression, f of 1/2 x plus 4, is there some function we don't know about, like sine of 1/2 x plus 4, square root of 1/2 x plus 4, 1/2 x plus 4 to the third power. We just don't know what function they're talking about, but it's some composite function that somebody's taken function and put 1/2 x plus 4 in. So I'm going to let u be 1/2 x plus 4. Du is 1/2 dx, so 2 du equals dx. I use these two for my sub. All right, so now I've got the integral of f of u, which is 1/2 x plus 4, and now I've got to be careful with du. When I take out dx, I'm sorry, let me do it up here. When I take out dx, I get 2 du. And then I'm going to change my limits of integration. So a was 2. Fill it in here, and you get 5. B is 10. Fill it in here. Half of 10 is 5 plus 4. You get 9. So I'm going to make this 5 and 9. All right, so now let's look back at what they told us. They told us if we did all this, we should get -8. So now I'm going to divide by this 2. So I have the integral from 5 to 9 of f of u du equals -4. Divide by 2. So it equals -4. All right, so this should equal -4. I think I might have this one pulled up in my Delta Math. Sorry, there's socks. Okay. So 5, 9, and this equals -4. Okay, and I'll show it to you sort of in a little bit different way than what I did. All right, let's go to the next one. Let's try another one, because they could ask you all sorts of things here. So let me take a picture of this. Let's see if I can, hang on, sorry. Let me go back. Okay, so now what did they tell us? Let f be the function that is given right here. What must be the value of this? All right, so I'm going to let u be 1/3 x. Du is 1/3 dx. 3 du equals dx. So let's sub in. So I'm doing this. So I have f of u, and dx is 3 du. And then my number's just going from 0. So if I put in 0, I get 0. And if I put in 9, I get 3. All right, now they tell me, they give me a little clue. They tell me that if I took 0 to 3, it would equal 12. So I know the integral from 0 to 3 of f of u du, I know that this whole part is equal to 12, and 3 times 12 is 36. So that gives me the value of the original function, which is right here. So I just sat down to work it out and just see where it takes me. So let's put in 36. Okay. All right, let's see what the next one does. So don't let things like this scare you. It's going to be okay. Just work the problem out and see what happens. A lot going on in the dorm if you can hear the background noise. I don't know. Probably should go check and see what's happening. Okay, so it says a lot here, but I think I'm just going to work it out and see what happens. All right, so I have the, I'm going to say u is equal to 1/4 x squared. And this just means there's some function they're not telling us. Du is 1/2 x dx. 2 du equals x dx. And then let's work it out. So I have f of 1/2 x squared plus 1/4 x squared, which is u. So I did this. Dx is 2 du. Sorry, x dx. This whole thing right here is 2 du. And my new numbers. -4, fill it in here, and you get 1/4 of 16. So you get 4. And then if you fill in 2, you get 1/4 of 4, so you get 1. All right, now what are they asking us? So let me erase some of this so we can read it. All right, so we have all this given information, and we want to express it in terms of A, B, C, or D. All right, so G prime is equal to f of x. All right, so I have 2 times, and then I know that this integral, if I go backwards from f, will give me g of 1 minus g of 4. So our clue here is the derivative, the antiderivative of f would be g, because g prime equals f. And so if you take the antiderivative, you go back to g. And then g of 1 was b, and g of 4 was d. So I guess I could just type it in like that. Let's try it. 2 times b minus d. 2 times b minus d. Okay. All right, so hopefully that'll help. I think that maybe your homework will go better if you do the work out of the packet first and then you do this.